right, here's part 2 of learning target 8. We're going to use Hess's law to calculate heat of formation from enthalpies of combustion. And you're going to need your data booklet. Open up to table 13 and give me a second while I shift things here. All right, so one of the ways that we can use Hess's law is we can come up with the enthalpy of formation of a particular organic compound, knowing that it can be formed from the enthalpies of combustions of each of the elements. So what we're going to do is we are going to look at the formation of ethane, C2H6, and we're going to use the combustion data in section 13 of the data booklet in order to come up with the enthalpy of formation. So, step 1 with any of these Hess law problems that asks you to come up with the enthalpy of formation from enthalpy of combustion is you always write your balanced chemical equation, just like we usually do. So, we've got carbon added to some hydrogen to make some C2H6. And then we need to go back and balance. So we'll need 2 carbons here. We'll need 3 moles of hydrogen gas here. So I've got 2 carbons, 2 carbons. 3 times 2 makes 6 hydrogens, 6 hydrogens. So there's step 1. So the next thing I'm going to do is I'm going to write out the combustion reactions for all 3 of these species here, for carbon, for hydrogen, and for ethane. So to do that, I'm going to say, all right, combustion means I'm burning an oxygen. So I'm going to have C plus O2. And this is just going to be forming my carbon dioxide gas. That's reaction number 1. Then I've got hydrogen. And if it's also going to react with oxygen, it's going to make some water. And I'm going to make water like this here. I need to go back and balance that one by adding a 2 here and a 2 here. I can also say for this one as well, I can say H2 plus half O2 to make 1 mole of water. In fact, I like that way a little bit better, and you'll see why when we do Hess's law on the next screen. And then the last thing we're going to do is the combustion reaction for ethane. Got to do them for all 3 here, because each one of these combustion reactions has its own particular enthalpy of combustion. So hydrocarbon burning an oxygen, you'll always get carbon dioxide and water. And I'm going to go back and balance. Throw a 2 here, because there's 2 here. Throw a 3 here, because 3 times 2 makes 6. Then I've got 4 plus 3 makes 7 oxygens on my right. And I only have 2 on the left. So in order to make sure I still have 1 mole of what I'm trying to make here, the ethane, one trick I can do is if I got 7 oxygens on the left, I'll have 3.5 or 7 halves O2 on the left-hand side. So what this means here is I've got a total of 4 plus 3 makes 7 oxygens on the left, and I have 7 halves times 2 makes 7 oxygens on the left-hand side. And this is a nice little trick to do because I still want this to be 1 mole, and it is. All right. So let's look at how we use these equations on the next slide here. There's our equations. And I pretend I opened up my data booklet and I paged through to find the enthalpies of combustions for all 3 of these. And now I'm going to use these step equations in order to come up with my goal equation, just like I did with the carbon monoxide example in the last video. So I'm going to go shopping here. I'm going to shop for some carbon. Carbon is located in this first equation here, but I need double that. So I'm going to have 2 C's plus 2 O2s to make 2 CO2s. And what's going to happen here is I'm going to have 2 times the negative 393.5 in terms of my enthalpy values. So carbon, boom, taken care of. I'm going to shop around for some hydrogens now. Hydrogens come from this second equation. So I'm going to need 3 H2s. So I got to triple everything. Plus 3 times a half is going to be 3 halves O2 to make 3 H2Os. So I'm going to need to triple my enthalpy of combustion of that second reaction. 3 times 286, negative, because it's exothermic. And then the last thing here is I've got to shop around for some ethane. And the ethane here comes from this equation, but notice that the ethane is on the left in my step, right on my goal equation. So what I'm going to do is I'm going to flip everything. I'm going to say 2 CO2s plus 3 H2Os will make C2H6 plus 7 halves O2. And since I flipped it, that's going to turn into a positive 1,561 kilojoules. All right, so let's see if our step equations, the way we wrote them, is going to end up making our goal equation. If things are redundant on the left and on the right, I can cancel those things out. So I can cancel out the CO2s. I got 2 CO2s on the left, 2 CO2s on the right, so that's gone. I can do the same with water. Water is now gone. And then let's see if my oxygens cancel out, or enough of my oxygens cancel out here. Because remember, my step equation is just the carbons and the hydrogens. So I've got 2 plus 3.5, that's going to end up being, 2 plus 1.5 is going to be 3.5 oxygens here. And I've got 3.5 oxygens here with 7 halves. So all my oxygens will end up canceling out. So I have made that goal equation. Got 2 C's plus 3 H2s will make 1 mole of my C2H6. So my last step is just to now add up my enthalpies of combustion, and that will give me the enthalpy of formation of my ethane. So I'm going to grab my calculator here, and I'm going to add up 2 times negative 393.5 plus 3 times negative 286 plus 1561. And to form ethane gas from its elements, I will release 84 kilojoules per mole. So, in the next part of this video here, what we're going to do is we're going to make what we call an enthalpy diagram out of this. If you just give me a moment to shift gears here. All right, so IB really likes this idea of enthalpy diagrams. And enthalpies of formation can be calculated by looking at enthalpies of combustion. And that's because when we're forming compounds from elements, it involves an incredibly high amount of heat and an abundance of oxygen. And that's how a lot of these compounds are formed, or through combustion. So if I can model how to get the enthalpy of formation of a compound through the enthalpy of combustion of its elements, it will be clear how this thing is formed, or how the compound is formed. So you're going to see this is called an enthalpy diagram, and it's the same thing that we did on the last screen with Hess's law, it's just going to be mapping it out. And I want to show this to you because this is what you're going to see on some of the IB questions. So the first thing we went ahead and did, if you remember in the last part of the video, is we doubled the amount of carbon we needed in our goal equation. And so we added 2 moles of the oxygen there. Here, what we did is we added 7/2 or 3.5 moles of oxygen gas in order to get the CO2 plus the H2O. And notice here that these are the products that make the ethane. And to get the ethane, what we went ahead and did is add the 3 H2Os plus the 2 CO2s to make the C2H6 that you see up here. So combusting carbon with 2 moles of oxygen, 2 moles of carbon combusted with 2 moles of oxygen will make 2 moles of carbon dioxide. Combusting 3 moles of hydrogen with 3.5 moles of oxygen will make 3 moles of water. Those two things added together will create ethane. So the cycle goes from here to here, from here to here. Those two things have to happen first in order to go here to here. So that is what we call an enthalpy diagram. We'll do more examples of those a little bit later on. All right, so you're going to see a couple of practice problems that go along with this, with Hess's law, and we'll talk to you soon.